Hello, ladies and gents. Hopefully you tried these review problems ahead of time, and now you'll just kind of check in for your solutions and any little tips if you needed some hints. Let's see. We're evaluating this limit. What are the function values approaching as my x values approach -1? That's a quadratic, no problem spots at all, so I can just plug in -1. 3 times -1 squared plus 4, which is just 3 plus 4, which is 7. So no problems there at all on that polynomial, that quadratic function. All right, we got some problem spots on this next one. Where is this function q of x continuous? It's not continuous everywhere. If I graphed this thing and traced it, I would have to lift my pencil when tracing that function. So this is not a continuous function on the entire domain. Let's see where those discontinuities occur. If I factor that denominator, please notice that I get some problem spots in the denominator. I will have vertical asymptotes at x equals plus or minus 3. So I'm going to say q of x is continuous at all x not equal to plus or minus 3. Or you can say continuous on the intervals -infinity to -3 united with -3 to 3 united with 3 to infinity. Continuous everywhere except x equals plus or minus 3, or continuous on all of those intervals. Either way is perfectly fine. What is the limit as x approaches 7 of this simple little function f of x equals 11? What does f of x equal to 11 look like? That's a horizontal line at y equals 11. And as my x values approach 7, my function values, of course, are always 11. So that's the limit of a constant function. Alrighty, let's keep cruising. Find the limit as x approaches -2 of the average rate of change of this function f of x. When I see average rate of change, I think slope. So I ask myself, what does the slope approach? What does the slope approach as x approaches -2? How do I figure that out? I'm going to find the limit as x approaches -2 of the average rate of change. Change in y for any x value approaching -2. Change in y is that x value minus f of -2 over change in x, which is x minus a -2. Alrighty, let me clean that up a bit. So that is the limit as x approaches -2. What is f of x? That's the function itself. 4 minus 3x minus. Off to the side, I need to find what is f of -2. What is f of -2? That's 4 minus 3 times -2, which is 4 plus 6, which is 10. Alrighty, all over x plus 2. I can't simply plug in x equals -2 because this fraction is undefined there, so I have a little work to do. That's the limit as x approaches -2 of what is that, -3x minus 6 all over x plus 2. I'm going to pause and factor that. Once I factor out that -3 from the numerator, I can eliminate that problem spot, and the limit is approaching -3. So as my x values approach -2, the slope is approaching -3. Alrighty, in hindsight, go back to this function. That's just a linear function. The slope is always -3. So the calculus does check out. Alrighty, I'm going to ask you to evaluate the limit as x values approach 2 of this function 1 over x minus 2. What does that equal? Notice I can't just plug in x equals 2. It's undefined. I can't factor and eliminate that problem spot. Okay, so since this thing is undefined at x equals 2, I need to get a little bit more creative. I'm going to ask you to look at the graph. Okay, pause and graph that thing. The denominator tells me I have a vertical asymptote at x equals 2. My function looks like this. Please notice that this function is not approaching a value as x values approach 2. Therefore, this limit does not exist. Nicely done. Alrighty, let's move on. Where is this function, f of x equals 4 cosecant of x, continuous? I'm going to ask you to sketch that function. Do you remember that a cosecant function has asymptotes? So since it has asymptotes, you know it's not continuous everywhere. Remember that to graph a cosecant function, we actually graphed y equals 4 sine of x first. Let me give you a second if you have not to graph that, and I'll sketch my graph. Okay, there's my stretched sine curve. I know where my asymptotes are. I sketch my cosecant curve. And notice this function is continuous on those nice little curves, but I do have to lift my pencil. Where do I have to lift my pencil? F is continuous for all x not equal to, I'm going to say integer multiples of pi. If I ask you to evaluate this next limit of this function as x approaches -1, if I plug in -1 into that denominator, it does equal 0. So this function is undefined at x equals -1. And our goal then is to fix this problem spot. Think about how to fix that problem. Okay, in order to fix this problem, I can either factor by grouping and eliminate the problem spot, or actually I could use my graphing calculator and in my table look for x values that are getting closer and closer and closer to -1 and see what those y values are getting closer and closer and closer to. I would think we all agree we need some factoring practice, so I'm going to do this by factoring by grouping. Let me pause. Okay, I grouped the top, factor out an x squared from those first two terms and a 3 from those last two terms. Factor out an x cubed in the denominator and a 2. Then I can take out those x plus 1s. I can remove that problem spot factor. Now I can plug in -1 to what's left. And I'm left with 1 plus 3 in the numerator, -1 plus 2 in the denominator, and that limit approaches 4. Again, you can verify this in a table of values with your graphing calculator, but the algebra is good practice. Alrighty. Please look at number 8 and check your work. You know what? This is one limit that we're just going to ask you to memorize next year. Alright, so we'll start to memorize it. The limit as x approaches 0 of tangent x over x is undefined when x is equal to 0, but the value of this limit is simply equal to 1. Make a list. Two other ones that we'll memorize next year. One is the limit as x approaches 0 of sine of x over x. We've used it a few times now. Is simply equal to 1. And another one we will memorize is limit as x approaches 0 of cosine of x minus 1 over x, and that limit is equal to 0. Those are three that you're simply going to have to memorize and be familiar with. Okay, you ready? This is just some nice semester review. So you're saying, why were these in here? Well, it's a good time to practice what we've learned this semester. So I thought we'd just kind of throw these in there, and we might as well learn from them. If you were asked to evaluate sine of 3 pi over 2 plus tangent of pi, this is just a good old unit circle question. What is that ordered pair down here at 3 pi over 2? That is 0, -1. Sine is y, so this is -1 plus tangent of pi. Tangent pi is over here at -1, 0. If you remember, tangent is y over x, that's 0 over -1. -1 plus 0, which is simply -1. All right, give yourself a little pat on the back on that one. Oh my goodness gracious, convert that polar coordinate to rectangular coordinates. So you sketch that thing. Remember, a negative angle goes counterclockwise over here. But now my r value, remember that was r theta, is negative, so that asks me to move 3 units across the pole. And rectangular coordinates means this. nice and rectangular, and I want to find that ordered pair. Let me pause to save some time. Okay, notice if this was 3 pi over 4, in the first quadrant this is a 45, 45, 90. There's my pattern, so that means that my x root 2 side is equal to 3. Take a moment and solve for x. If x root 2 is equal to 3, divide, rationalize. It's a nice isosceles triangle in the first quadrant, so my rectangular ordered pair is 3 root 2 over 2, 3 root 2 over 2. All right, little review of our inverse trig functions important for next year. Do you remember that for inverse cosine, I input a number, output an angle? So really, I just want to figure out what is the tangent of that angle. Do you remember the range for inverse cosine? The range for inverse cosine was only quadrants 1 and 2 from 0 to pi. Since this cosine value is positive, I'm going to draw a triangle in the first quadrant. Cosine of that angle is 2/3, so adjacent over hypotenuse, and find that missing side. I'll say a squared plus 2 squared is equal to 3 squared. Solve for a. What is that? 9 minus 4, which is 5. A squared equals 5, and a is equal to the square root of 5. So really, here's my angle theta in the first quadrant, and I just want the tangent of that angle. So, TOA, opposite over adjacent, which is root 5 over 2. Alrighty, so remember those ranges of inverse functions we have to keep in mind. Alrighty, let's keep going. Last two, refresh your memory on this one if you need to. Let's see, find the sum of the sequence, just to keep this fresh. Find the sum of the sequence. When I look at this pattern of numbers, and then I'm going to add them all up, they're increasing by 2. Each of the next terms is increasing by 2, so this is an arithmetic sequence. If this is an arithmetic sequence, I know how to find the sum of an arithmetic sequence. The sum of an arithmetic sequence, S of n, is equal to n over 2 times the first plus the last. The problem is I don't know how many terms are in this sequence. I don't know how many terms that is for that n right there, so that tells me I need to find n. How do I find n? I use a sub n is equal to arithmetic sequence. The general term is the first term plus n minus 1 differences. Let's plug in what we know. The nth term, 59, is equal to the first term, I know it, which is 1, plus I need to solve for n minus 1 of those common differences, which is 2. Take a moment and solve that as I do. Okay, solving. Divide both sides by 2, n minus 1 equals 29. I get the number of terms is 30. Plugging back into my sum formula for an arithmetic sequence, the sum of the first 30 terms will be 30 divided by 2 times the first, which is 1, plus the last, which was 59. S sub 30 is equal to 15 times 60, and I get the sum of the first 30 terms is 900. Alrighty, just for a little practice. Haha, this is good practice. Solve the equation just over the first unit circle, which is from 0 to 2 pi. Let's see, this thing factors. Take a moment and factor that. What is that? 2 cosine theta. Cosine theta. I want that middle term to be positive, so this can be a plus 1 minus 1. Use the zero product property to solve 2 cosine theta minus 1 equals 0, or cosine theta plus 1 equals 0. Take a moment to solve. This gives me cosine theta is equal to 1/2. Cosine is x, so that's up top. Down below gives me theta values of pi over 3. Down here in the fourth quadrant, 5 pi over 3. When is cosine equal to -1? That's over here at pi, and I get 3 solutions to that trig equation. Thanks for watching. Have a great day.